One of the first things you learn when programming in R is there's a bunch of built-in functions for performing common calculations. For example, there's the mean function, the standard deviation function, the sum function. These are just built into R. We can invoke them, we can pass it any data we want to run our calculations on, and it's going to return as a result. Looking beyond these built-in functions, you can also include external packages where other developers have come up with their own functions that you can utilize within your code. But looking beyond these off-the-shelf solutions, sometimes you'll find a need to write your own custom functions. You'll want to do this whenever there's some sort of repeat action in your code that you need to perform multiple times within a script or even across scripts. And rather than repeating that code, you can encapsulate it in a function and then invoke it whenever you need it. For a very basic example, let's define a function that will determine if a number is even. The first step is coming up with a name for our function. So I'm going to call it isEven. And then I'm going to assign this to R's function keyword. And then following that, in parentheses, I'm going to indicate what parameters this function might take. Parameters are like the ingredients of a function. It's the information we're going to pass in that's going to be used within the function to perform whatever calculation or operation that we define. In this case, if we're using this function to determine if a number is even or not, we need to be able to pass in the number we're looking at. So I'm going to define a single parameter, and I'm just going to call it num for short. If I needed to pass in multiple bits of information, I could indicate multiple parameters. I would just separate them by commas. After we've defined our parameters, we're going to use an open and close curly bracket to indicate the start and end of the function. So any code I write in between these curly brackets makes up the body of the function, and it's going to be executed when I invoke this function. So here's where we need to get to work and write out our formula for determining if a number is even or odd. And one way we could do that is we could take our number and use the mod operator, represented in R by 2% signs, and we're going to divide by 2, or mod by 2. And the mod operator is just going to tell us what remainder we get when we divide two numbers. So if we take our number divided by 2 and the remainder is 0, well, then we know it's an even number because it was evenly divided by 2. All right, so that's like the crux of what this particular function needs to do. And then the final thing we need to happen is we're going to wrap this in a return. So I'm going to say return and then open and close parentheses. And then the value I want returned is my formula here. This is going to be either true or false. So the end result is when we invoke this function, it should return to us either true or false. Let's test this out. So to invoke a function, we're just going to reference the name of the function and then pass it any parameters in parentheses. All right, so we know that this function takes a number. So let's start with the number 1. Let's see if that's an even number. I'm going to make sure I load my function into my current working environment, and then we'll execute our function. And as expected, you can see it's returning false. Let's try isEven 12. As expected, that's yielding true. And so on and so forth. You can test this out with any numbers you want. For another example, I'm going to go over to the notes that accompany this video, and down under functions with no returns is another example function we can look at. So I'm just going to copy that and bring it into my script. All right, so this function is called save to CWD, where CWD is short for current working directory. And one of the things you can observe about this function, in contrast to our isEven function, is it takes two parameters. The first is the data we want to save, and the second is a file name for that data. The other thing you can observe about this function is there's no return statement. So this function doesn't return a value. Instead, it has like a side effect. It performs some action, which is to save our data to the given file name. It also outputs a message confirming that the file was saved. All right, so keep that in mind. Depending on what your function needs to do, sometimes it just performs some sort of calculation and returns a value. Other times it has a side effect and it performs some action. Or sometimes it might do both. Maybe instead of this output message to the console, or in addition to, we also have a return statement that just simply returns true, indicating that the file was successfully saved. Whether or not your function has a return statement, this really depends on the goal of that function. The last point I want to highlight about functions is they can be organized into their own files, which can help streamline your main script files. For an example of this, let me bring up my file explorer, and I'm going to create a new file. I'm going to call it utils. And then within this file, I'm going to put just my functions. So just pulling from this example, we'll take our isEven function, and we'll also take our save to current working directory function. We're going to outsource it to utils. Then back in our main script file, we still want to use these functions. So at the very top, I'm going to say source and indicate the path to my utility functions, which is utils.r. So now if I load that, I can still access things like my isEven function, and if I had invoked my save to current working directory, I could invoke that too. So keep that technique in mind. It can really help organize your scripts and also give you modularity and reusability. To the extent that you have commonly used functions in here, you could then source it and include it in other files and not have to constantly redefine the same code over and over again.